widely acknowledged that the accumulation of carbon dioxide in the atmosphere is contributing to the greenhouse effect and hence global warming. The challenge we face is to reduce and ultimately try to eliminate anthropogenic carbon dioxide emissions. Refining oil is an energy and hence carbon-intensive process. It is believed that 5% of emissions worldwide are released from refineries such as this one. We hope to demonstrate to you how we'd use the process of photosynthesis to create a carbon-neutral refinery by the year 2030. The natural cycle of carbon has existed for millions of years. A crucial step within this cycle is the synthesis of carbon dioxide by plant life. The photosynthetic efficiency of algae and the fact that it can be grown in diverse environments mean it is the ideal organism to be used to capture carbon dioxide. So we found algae to be the best organism for absorbing carbon dioxide. How could this be implemented?
Algae can be grown in various ways. One method uses photobioreactors placed inside a greenhouse as a controlled environment. The flue gas from the refinery will flow into the photobioreactors to be consumed by the algae as part of the photosynthesis process. And this is how it's going to work.
At the refinery, crude oil is processed and refined into petroleum products. In this process, large amounts of flue gas is released. The process starts when seawater is pumped from the sea and filtered to remove any contaminants. The algae is mixed with seawater and pumped into the photobioreactors. At the same time, the various flue gas streams are captured, treated, and channeled into the photobioreactors. Sun energy is used by the algae to synthesize carbon dioxide into oxygen and complex sugar molecules. The oxygen is then captured for further use. The water-algae mix is drained from the photobioreactors and dried, creating powder-like biomass. The biomass is used to produce various products. The products can be transported to the various markets or fed back into the oil refinery.
So we've seen the carbon capture process. What can we use the algal biomass for?
So, we have many opportunities when it comes to algae products. Because some algae strains have a high oil content, we can extract what's known as green crude, which can then be used back in a refinery for power generation or be used to convert into biodiesel. We can also use the leftover algae starch and cellulose to convert into bioethanol, which can also be used as a fuel additive or be used in the production of biodiesel. Aside from biofuels, there is a growing market for algae-based nutraceuticals such as carotenoids and omega-3 fatty acids, and research is being conducted which can bring algae into the pharmaceuticals market also.
The model site will include the following facilities: water distillation, wind turbines, production area, glass houses for the photobioreactors, and an eco-park for the surrounding communities.
The financial estimates to the year 2030 are as follows. The site would cost approximately £300 million to construct, with annual operating costs of £12 million. With revenue streams from algae products and carbon capture, it is estimated the site would break even by the year 2027. These figures show that as well as being a huge step towards sustainability, the system can also be financially sustainable. As the world's population continues to grow, so does the demand for energy. If this demand is to be met, new sustainable technologies will need to be introduced alongside traditional ones.
We are aware of the impact that the increase in energy demand is having on our planet, and we must develop technology to guard against these harmful waste products.
Team Aspire had demonstrated a method that tackles these two fundamental challenges simultaneously. By harnessing nature's ability to absorb harmful emissions and produce products, the environment will be protected while the energy demand is met. So here's the future of carbon capture. Cheers!
Cheers!